All right, so we're going to do the first part of our fraction book. Everyone got one of these in the mail. And what we're going to do is we're going to work on a couple of these. So the first one, we're going to, on the little arrows here, we're going to put what we're covering. So in this one, we're going to write fractions of 1 and the letters L, C, D. Okay, that's going to be our first little tab. And what we're going to do then is we're going to open this up like so. Okay, and we're going to write on the top here about fractions of 1. Okay, so fractions of 1. So we're going to put a bunch of different kinds of combinations here for you to see. And we're going to have examples. So any number divided by itself. So here I have 1 over 1, 12 over 12, 1,000 over 1,000, -2 over -2, and even x over x. All of these are examples of what a fraction of 1 is. So let's write down a definition here. It's going to be any number or variable divided by itself equals 1. Okay, so that's going to be what we're talking about. We talk about fractions of 1. Any number or variable divided by itself equals 1. And those are our examples. And we're going to talk about using fractions of 1 quite a bit. So we have to understand what we're talking about when we say fractions of 1. Okay, in this next section here, we're going to talk about those 3 letters that we wrote a moment ago, L, C, D. And what those mean is least common denominator. And because we're talking about fractions, we're going to talk about denominators a lot, and we're going to talk about the least common denominator. Another word could this be is also least common multiple. So I'm going to put the word multiple in parentheses there. Multiple means to multiply, so we're going to be looking at multiples and what's going on. So let's practice here. We're going to take 2 numbers. We're going to take the number 2 and the number 4. And what we're going to do is we're going to write the multiples of these numbers. So we're going to start counting. 2, 4, 6, 8, 10, 12. We're going to go all the way to 20. 14, 16, 18, and 20. And we're going to do the same thing for 4. 4, 8, 12, 16, and 20. Okay? So we're going to take a look at these numbers, and what we're going to do now is we're going to say, okay, what numbers do they have in common? We can see that they both have the number 20 in common. They have the number 16 in common, the number 12 in common, the number 8 in common, and the number 4 in common. So all of these are considered, if I get rid of the word least, these would all be considered common denominators or common multiples, okay? But there's only one of them that can be considered the least common multiple or the least common denominator. And for us, the LCD here would be 4. Okay, so that's something to think about. We're going to practice a couple more because we need a couple of examples in our book. So we're going to do it again for the numbers 3 and 12. So we're going to do by 3s all the way to 36. So 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, and 36. And then we're going to count by 12s to 36. So 12, 24, and 36. Okay? So in this one, common numbers or common multiples that they have, and if these were in the bottom part of the fraction, they would be denominators, right? So 36 is common, 24 is common, and 12 is common. All of those are common, but for this one, the LCD happens to be 12, the least, the lowest common number that is available. We're going to do it one more time, and this time we're going to do it for the numbers 3 and the number 4. So we're going to do it to 24, okay? 3, 6, 9, 12, 15, 18, 21, and 24. We'll do the same thing by 4s. 4, 8, 12, 16, 20, and 24. We're going to find those common numbers. Here they have 24, and we have 12. Okay, so there's our common numbers. And for us here, our least common denominator, or least common multiple, would be 12. Okay? All right, so far that's the beginning of our flip book. We're talking about fractions and least common denominators. We're going to do one more in this video, okay? And this one's going to be called simplifying rules. Okay, it's really important to understand how to simplify. And if you are really good with your numbers and your multiplication tables, this is easy. If you're struggling with your multiplication tables, this can get a little bit difficult. Okay, so let's turn our page in our book up. Okay, and we're going to go up here in this yellow section here. And what we're going to do is, first we got to do some definitions, okay? We have a fraction, and a fraction is going to have a numerator, which is the number on top, and the denominator, which is the number on the bottom. This is what makes up a fraction. Okay, so we're not going to be calling this number on the top, number on the bottom. We really have to get used to these words, okay? And another word that I'm going to use quite frequently is the word factor, okay? And a factor is a number that, and I'm going to use a phrase that you guys like to use, goes into, all right, another number. So we're looking for multiplication math facts. Okay? So that's what we're looking for. That's where the word factor comes from. They're math facts. We're looking for some math facts. Okay? So first thing we're going to do is we're going to write down our rules. We're going to put down some examples here, but we're going to write down our rules up here for some math facts. So here's the first one. Okay? If both numbers are even, okay? So if both numbers are even, every even number in the world can be divided by 2. So we're going to write divide by 2, and I'm going to put it like this so that we see it, divide by 2. So if both numbers are even, we're going to be able to divide by 2, okay? Here's another rule. If both numbers end with a 0, okay, if both numbers end with a 0, what we would do then is divide by 10. Because we know like 10 can go into numbers like 20, 30, 40, 50, and so on. Okay, so we're going to divide by 10 if they both end with a 0, that they'll have that in common. Okay, although there's another rule for both ending with 0, so we're going to add another one here for both end with a 0, because this will be both end with a 0 or a 5. I bet you guys know that rule, right? Because sometimes I'm sure you guys thought about it up here. But if it does that, that means that we can divide by 5. Okay, divide by 5. So that means that 5 can go into any numbers ending in 0 or ending in 5. Okay, now here comes a fun one that I like. Okay, you ready? This is the 3 rule. So we talked about the 2 rule, the 5 and the 0 rule. Now this is the 3 rule. Okay, both have digits, and you guys know what a digit is, right? That's a number. When added, are divisible by 3. Okay, both have digits when added are divisible by 3. In other words, we're going to divide by 3, right? So try and squeeze it in here. Divide by 3. Okay, and I'm going to give you a couple examples of what I mean by that. Okay, so let's take the number 12, right? We know 3 can go into 12, and the reason for that is because the digits 1 plus 2, those are the digits 1 plus 2. Well, 1 plus 2 equals 3, and 3 can go into 3. So let's do it with a bigger number to show you how this works. 369. If I take those numbers, 3, 6, and 9, I add them together, and I get 18. Okay? So, and we know that 3 goes into 18, so if 3 can go into 18, then 3 can also go into 369. That's how we come up with these divisibility rules. Okay, and then there's one more, and we're going to kind of roll on to this one down here. Let's go down here and go back into this color. I'm changing colors so it sticks out a little bit more for you guys. We're going to double check, that's what I mean by that. We're going to double check for 7s, 11s, and 13s, because those are special ones that tend to show up quite frequently when we are doing some simplifying of fractions, some simplifying rules. So right now we're going to practice this, okay? So here we go. So we're going to put our examples down here. That's why we have a lot of room. We're going to do like 5 examples right now. So let's go with example number 1. 2 over 4, okay? So we know according to our rules, both of these are even, right? So remember our rule up here, if they're both even, divide by 2. So let's divide both of these by 2. Now there's our fraction of 1, right? We were talking about doing things to fractions. Now remember, if we wanted to have the exact same value, the only thing we can do is multiply 1 or divide by 1, because it doesn't do anything to the number. But what it does do to a fraction is either makes it smaller or larger. In this case, because we want to simplify, we want to make it smaller, we're going to do it this way. So now we just do a little bit of math, right? So we'd say 2 divided by 2 is 1, and 4 divided by 2 is 2. So that's how we simplify a fraction from 2/4 down to 1/2. Remember, we use a fraction of 1 to get us where we need to be, and that's why we talked about fractions of 1 the first thing we did, because fractions of 1 are going to help us change what we see. Okay, because let me ask you a question. I'm going to throw a little sticky on here while we're thinking about this. Okay, like if I wanted to say 3 and I still want it to be the number 3, I would multiply it times 1. True? And the same thing, what would I divide 3 to get 3? I would also divide it by 1. So we know that multiplying by 1 or dividing by 1 gives us the exact same number, and we don't have to worry about changing anything. So we do the same thing in the fraction world. If we want to simplify the fraction, we would divide by a fraction of 1. If we want to change the denominator to make it bigger, we would multiply by a fraction of 1. And that fraction of 1 is going to come into play when we start to combine fractions. All right? Okay, let's go over here. Let's do example 2. Okay, so for example 2, let's do 30 divided by 50. So when we see that these both end in 0, and we go back up to our rules here, when both of them end in 0, we're going to divide by 10. So that's going to be our fraction of 1, 10 over 10. Okay, and then we're just going to do the math. 30 divided by 10 is 3, 50 divided by 10 is 5. Now this one's also divisible by 5 because it ends in 0, but it's going to make we do more work that way. So we always want to do the least amount of work. So we want to put the biggest number we know inside of it. Okay, so let's go over here to example 3. And here this time I have 15 divided by 30. So if we follow our rules, right, this ends in a 5 and a 0. So numbers that end with 5 and 0, we're going to divide by 5. So we're going to divide this one by 5. There's our fraction of 1, 5 over 5. And we find that 15 divided by 5 is 3, and 30 divided by 5 is 6. But this is still the fraction rule, right? These are both divisible by 3. 3 and 6 go into that. So we can continue this. We can continue to simplify, and sometimes that happens. We know 3 goes into both of those numbers, right? And so then we end up with 1/2. Now, we could have picked a larger number, couldn't we? 15 went into both numbers, things like that. So you can't pick larger numbers, but if you stick with these divisibility rules, even if you have to do it twice, it will help you if you struggle with this idea. Okay, so let's do example 4. Example 4 is 12 divided by 72. And then what we're going to do is we're going to think about that. Now, we can do the 2's, right? Because they're both even. But if we just think about, like we just did a moment ago, we were talking about if we had a larger number, we don't have to work so hard. We should know our 12s, I would hope, and know that 12 goes into both of these numbers. So I can divide it by my fraction of 1 being a 12, and I will end up with 1 divided by 6. Okay, one more example in this simplifying rules. Example 5. We're going to use 11 divided by 55. Now, this isn't going to follow any of my rules here. They're not even. They don't end in 0. They don't have digits. When they add up together, it gives me something divisible by 3. So none of this. So it's really one of my specials. Is it divisible by 7, 11, or 13? And so we can see if we know our 11s that this one's divisible by 11. So we're going to divide it by 11 as our fraction of 1. Okay? And then we get 11 divided by 11, which is 1, and 55 divided by 11, which is 5. So now it's really important that you do these types of things this way. Please don't do this. I'm going to use this 1155s. Don't do this. This means something totally different. This is saying take 11/55 and put it into 11 pieces. That's not what we're doing, right? We're trying to keep the same amount of pieces but make it smaller, okay? We're not trying to change it differently. I don't want to divide this into 11 pieces. What I want to do is I want the same number but smaller. I want it reduced, because this is what we're looking for when we're simplifying, using our simplifying rules. Let's put the words in here, reduce. That's going to help us to reduce our fractions, and that's been a sticky point for some people. So I'm going to stop this video here. So this is our part 1 video.